why we are using energy modeling, and I will also show you one of my live project, and I will show you on the platform of energy modeling. From there, you can understand the things better. And in the end, we will do the Q&A session in which you can ask me any of your queries. So basically, what is simulation? Simulation is creating a virtual replica of a building in a software, analyzing the building for different parameters. So basically, what we are doing in simulation is we are making a virtual building, and we are optimizing the building with different parameters, with different input parameters. Like if we talk about the envelope, basically we have roof, glazing, walls, HVAC, then we have the lights we have. All these parameters we give inputs in the software, and then we'll check and optimize the system for the energy efficiency. So simulation is very broad subject. Basically, in simulation, there are various types of simulation. So let me show you. These are the sort of simulations available in the market, and various different sort of people who have expertise in different simulation things. They use the different software. Like for the simulation, energy simulation is there, and wind simulation, CFD, computational fluid dynamics simulation, daylighting simulation, artificial lighting simulation, fire simulation, and many more. So there are lot of simulations in which what we do is we give the particular inputs, we check many of the things which are associated with each other, and then we'll see how we can optimize the building. So this is what the simulation definition is. Then let's talk about the modeling. So modeling is basically a part of simulation only. But in modeling, if we talk about the energy modeling, if we have particular inputs, like if we have some fixed inputs and then we'll do the ECMs, then that sort of activity is known as modeling. So this is what about the simulation and modeling. Now let's talk what is the use of energy modeling. So typically, energy modeling is used for the sustainable building credits. As you all know, there are various councils which are giving green certifications like LEED, IGBC, GREHA, JAM, BREEAM. So these all councils, to get the points, we need to do the energy modeling. Basically, we do the energy modeling for the sustainable credits. These are the energy credits. Then we have the incentives programs like FAR. So if we all know, like if we have the green building certification, we can target the extra FAR, which is floor area ratio. So like IGBC also giving, JAM is also giving this sort of thing. So for incentives program also, to get some incentive, we do the energy modeling and show the comply authority that this building is that much efficient. Then we have the code compliance, like various code compliance are available. IECC, International Energy Conservation Code, ECBC, which is our Indian energy code. So to comply all this code, we need to do energy modeling as per the criteria of every compliance, because every compliance have different baseline reference. Like for normally IECC, we use ASTRE standard. For ECBC, we have our own standard, and for IGBC projects or JAM projects, we use ECBC, which is ASTRE 90.1 for India. So these are the things we use for the code compliance. Then we have tax credits. So basically, in the Western countries, if you in US and European countries, we have tax credits on the energy efficiency. So if we are making a energy efficient building, which is more efficient than the baseline reference, then we can target the tax credits. So 1790, 45L, these all various laws are available in the US market where we can target the tax credits. Then definitely designing net zero building. So these days, various things are coming up for the net zero, like net zero water building, net zero energy building. So to make this building, we need to work on many of the input parameters, and then we correlate all the parameters and make the energy efficient building, which can be a net zero building. So in energy modeling, we need to use the renewable sources also like solar, geothermal, wind. Also, we can give the inputs of these renewable sources, and then we can optimize the building. So this is what we use for the these all segments we use for energy modeling. Now let's talk about the building components. So as you all know, for making a building, we need lot of things. So first thing is like the material, what material we are going to use. So that material can be like cement, steel, paints, different sort of paints. Then so all this part of these all parts of our material thing. Then we have the HVAC. In HVAC, basically we talk about the heating, ventilation, and air conditioning. So what sort of equipment we are going to use in the building, how much efficient is the system is, all this part of the HVAC system. And definitely control is very important part of energy modeling, the HVAC controls. This we are going to discuss in later sites, but definitely controls of lighting and the HVAC equipments are very important. Then we talk about the lights. So we have the interior lights, LED lights inside the building. Again, we have the occupancy sensors with the lights. So that is again important thing. So basically, ASHRAE 90.1 covers envelope, which is wall roof glazing. Then we have lights and the HVAC equipment. So these all things make a building component. So in building envelope, as I told you, we have three parameters, wall, roof, and glazing. So basically, these are very important parameters. Whenever we are talking about any energy efficient building, this is the passive approach we are going to use because for any active equipment, we are going to utilize the electricity. But by making the passive things, we can like if make the efficient building throughout its life. So on the walls, we can use many of the materials available in the market, like insulation. We have different sort of insulations, different sort of paints are available these days, and different types of blocks. AEC blocks are available, which are more efficient than the brick, red bricks. So these are the all things we use for the wall envelope. So basically, there is a word which is known as assembly. So whenever we are making a wall with different sort of components, that the complete thing is known as assembly. So we need to figure out what assembly we are going to use in the building and what is the thermal properties of that assembly. So basically, we need the parameter which is known as thermal conductivity U value. So we need to calculate the U value. If we have the lesser U value, the wall is more efficient, right? And this is again a reciprocal of the thermal resistance, which is the R value. So more the R value, less the U value, and the more efficient is our envelope, wall envelope. The same thing applies for the roof also. So in this way, we can make different sort of roofs with the underdeck insulation, overdeck insulations, and there are many materials available right now in India also because in the Western world they have already different sort of membranes and they are making the assemblies itself. But right now in India we don't have the compact assemblies, so we are making the assemblies on site and then we are making our building. So that's one thing. And let's talk about the glazing, which is very important because glazing and the skylight on the roof, the three values we need to consider is the first one is the SHGC, which is solar heat gain coefficient. Second is the U value, definitely. And third one is the VLT, visible light transmitter. So these three values are interrelated with each other, and we always need to see what sort of glass we are going to use in the building. And basically many types of glass are available in the market, like we have double glazed windows with the air gap inside, and then we have inert gases also like argon and krypton. So these sort of glasses with the inert gas, they are more efficient, and they just give the resistance to the heat to come inside the envelope. So that's the thing. So whenever we are talking about any energy efficient building, first we need to see is the making the envelope efficient. So we have this three sorts of component in building envelope. The second component is the lighting and controls. So definitely like 20 to 30% of any building, light is consumed the electricity 30, 20 to 30%. So before we are using like we have bulbs, then we have the CFLs. Now we are using the LED lights. So things are changing every day, and more efficient components are come, more efficient equipments are available in the market. So in energy, in lights also, we have sensors which are occupancy sensors, daylight sensors, which can work according to the lux level in the environment. So whatever lux level you required in the particular room, you can just give the sensor with the light, and that sensor will help you to just reduce the energy. So the lighting and controls are very important part, which is because they are taking 20 to 30% of overall bill consumption, electricity consumption. And this is the major thing, the HVAC systems, which are very important. HVAC systems normally consume 60 to 70% of the energy in any building. In HVAC systems, we have lot of equipments available in the market, and every day we are coming with a new technology because everybody wants to reduce the energy consumption. And in India, as you all know, 70% of the electricity is coming from the thermal power plant, the coal plant, which is again harming the environment. So definitely, we need to reduce the energy consumption, and we need to use the efficient HVAC systems. So in HVAC systems, we have lot of things like before, like 20 decade, 2 decade earlier, we have the window ACs, then split ACs came, and then we have different sort of chillers, air cooled chiller, water cooled chillers. Then we have right now we are talking about the heat pump, air source heat pump, geothermal heat pump, ground source heat pumps. So every day things are coming up which are more efficient, and we are talking of COP of 6.1 these days with the more efficient magnetic chillers and the geothermal heat pumps. So these are the things we use in HVAC systems, more efficient systems. Now let's talk about the simulation for energy efficiency in buildings. So this is we already discussed that how we can make the building energy efficient. So for that, first we need to do the design. So first part is the role of architect. So architect make the design of the building which is energy efficient, because first we need to use the passive approach. How we are making the building, what is the WWR, window wall ratio, what side of the building, how we are taking the orientations. These all things are very important as per architect point of view. So first thing is we need to do the passive approach, what best we can do. And the second thing is the material selection, that what material we are going to use in the building. Because right now things are changing because of the climate change, and everybody is talking about the carbon emissions. So definitely for any manufacturing of any product, they emit the carbon emissions, and after installation also they emit the carbon emissions. So for that, we need to use the material which are carbon free or they have reduced carbon emissions. These sort of materials we can use for the energy efficiency of the building. And then we have the active equipments like the lights, HVAC equipments, the miscellaneous equipments that we are going to use. So all this part of the energy efficiency. Now let's talk about the need of energy simulation. Why we need to do the energy simulation? So first thing is to predict the total energy consumption of the building from all energy related end uses. So why we are making the energy modeling is to know the what is the operating cost of the building. So we have lot of things in the building, so that every component in the building like HVAC, lighting, and equipments. So we need to know that how much consumption is going in HVAC, how much consumption is going in the lighting. So we can predict the thing, we can make the thing, and then we can optimize the system. We can suggest the ECMs, which are energy conservation measures, in which we suggest the client that, okay, you can put that sort of light, that sort of HVAC equipment, and in this way, you can reduce the energy consumption. So this is the one thing. Second thing is benchmarking existing performance against best practices. So we can make the energy model of existing buildings also, in which we do the calibrated model. So in calibrated model, basically what we do is we take the 12 months electricity bill and we will just calibrate the model according to that bill, and it will show us that which equipment is taking this much of energy and how we can optimize the system. So again, here we are talking about the ECMs, which is energy conservation measures, and in this way we can make the existing building more efficient. Third point is evaluation and appraisal of low energy measures and technologies to achieve targets. Definitely, there are various renewable sources available like solar, geothermal, wind. So we can again evaluate the thing. We can just keep these parameters inside the software and check how much they can help in reduce the energy efficiency. To analyze the effect of alterations in input parameters like altering the envelope, lighting, HVAC. These are same things again. How we can reduce the uh, energy consumption by making the envelope efficient and by making the lighting efficient and HVAC efficient. So we can just put many of the inputs parameter like take metal lights, and we can again correlate with the cost also, because we need to optimize the cost also. So we need to give different sort of combinations in the building, and we need to check how best we can do in that energy efficiency and definitely the cost also. To calculate the return on investment that are made for the implementation of energy conservation measures, definitely after doing all the calibrated model, and we need to see what are the ECMs we can suggest and how much cost the client have to pay for this implementation. So ROI calculation is most important, that after putting this sort of equipment or this sort of lights, how much energy we are reducing. So that is more important, because operating cost is we need to pay for operating cost every time, every month, and the capital cost is one time investment. We need to check the ROA also, that how much we are getting in the cost of amount. Energy simulation tools. Now let's talk about the what are the tools available in the market these days. And the first one is the eQuest, which is very common software and by department DOE, which is again from US. So eQuest is free software, and people are using it from decades to decades, and it is very efficient and friendly software. You can easily get the inputs and check what is the consumption coming up. So this is one software eQuest. Then we have IES, Integrated Environmental Solutions, Virtual Environment. This software is also again very famous in Western world, and in India also various consultants are using IES software. We are also working on IES software, and we are doing a lot of projects on IES. Then we have Train Press 700. This is also one of the software from Train. And then Design Builder. This software Design Builder is very common in European countries where they use to make the optimized building. This is again working on a energy plus simulation engine. So these are the tools we are using right now. So today I'm going to talk more about the eQuest software. What is the because we have like these four softwares I just told you, but many other softwares are also available like Transys we have, Cove Tool. There are many softwares, but these are the software which are very common everywhere. And today we are going to speak more about the eQuest software, which is free of cost, and many people are using it. And this is very old software. So eQuest software, we can work out for 8,760 hours, like for a year. For each day, we can do the calculations, can change the thing. We can work on the part load performance, because we have all the curves for the mechanical equipments, and capacity and efficiency correction measures. Again, we can make the correction in the curves as per the manufacturer, and all these things we can easily do in the eQuest software. So eQuest software is very friendly, and we can use it. So on eQuest, I will show you my live project after this presentation, in which I will show you the basic steps how to do the modeling and how we'll get the output. So the procedure is first we need to do the study of drawings. From the architect, we got the drawings and we need to study like what the complete structure, how many floors we have, and then we need to make the zones according to the applications or areas. Then we make the assembly of the building. Assembly is basically a work done in the AutoCAD in which we need to just overlap all the floors and then so that we can input the file in the software and make the 3D structure. So this is assembly part which we do in AutoCAD normally. Then we have equest wizard mode in which we can make the structure, we can give the height and internal and external zoning, window placing, all these things we normally do in the equest wizard mode. And then we have equest detailed mode. In equest detailed mode, we give the basic details of the parameters. Like if we have the overhang on the building, we can make the overhang there in the detailed mode. And then detailed working you can do for each of the parameters in the detail mode. And then we run the simulation after giving the weather file of that particular location. And then it will give us the output. So this is the procedure normally we follow for the energy simulation. So, first important thing is the import weather data. So, various sites are available on Google, which gives us the uh, data, the .bin file or EPW. There are various formats available on the Google. So, normally Energy Plus we are using because Equus is Energy Plus engine. So, in which we need to import the .bin file, and this can be downloaded from the Energy Plus website also, and then we need to give the utility rates. So that particular area location from where the building is, we need to give the utility rate of that area, and then we simulate the building. This is the format we are using. It will give us the final results. So now let's talk about data requirement. What are the data we require to make the energy efficient building? So first is the building location details. Definitely where is the building, what is the orientation, all this information we need. Second is the building schedules of the energy consumption. Schedules are like how the things are running and in the particular day. Like normally lights be on from uh, after 6 o'clock in the evening till 11 or 12. So these schedules we need to give. Ashray also have the standard schedules, and ECBC also we have the schedule. So definitely the schedules of the buildings are very important because that model will work according to the building schedules only. Then we have architectural drawings, definitely all the drawings we need, the elevation, section, and plan, summary of equipment and occupant loading under consideration. Now in building, we have the equipments also like if we talk about the residential building, we have refrigerator, we have washing machines and different sort of equipments. So that equipments also we need to give the inputs in the model to check how much they are consuming the energy. So this is equipment load. And then occupant loading is also important that how many persons are going to be stay in that particular space or building. So that occupancy density we need to give. Lighting load summary, like what is the LPD of the particular space, lighting power density that we need to give. Then HVAC load summary, that where we have the systems, FCUs, where's the thermostats, what is the efficiency of the system, and what is the fan power of the system, because indoor unit have the blower, so that blower also consumes some sort of energy. So that all sort of how much the power of that motor, we need to give all the inputs in the software itself. Then we have the details of miscellaneous load. So miscellaneous loads are basically if we are talking about a warehouse which is having a cold storage, so that miscellaneous load will be the refrigeration load, right? So this is the example I'm giving you. So miscellaneous loads also we need to take in the model itself to check how much it is consuming in a year. Then details of generation of energy by renewable energy sources. So if we have the solar PV or solar heater on the roof or in the building premises, we need to consider the inputs from solar also. So these are the data required to make the energy efficient building or the energy model. Energy simulation inputs, we already talked about it. So thermal loads, we need to check the first, what is the thermal load of the building. So thermal load is basically how much the heating and cooling load needed by the building after the design of envelope. So there are various again softwares available for the calculation of thermal load, like HAP. Normally people are using carrier HAP for the thermal load calculation, in which we'll see how much the load is coming. Like normally for the commercial buildings, it is coming high, 400 TR, 500 TR. For the residential building, it is coming around 10 TR, 15 TR. So this is all part of the thermal load calculation. Then we have the lighting loads. Lighting loads again, different sort of calculation in which we do how much lux is required in that particular area and what the wattage they are going to use. So this is the lighting load calculation. We have the equipment load. So if you are talking about the commercial office building, we need to see how many laptops, how many computers, how many Xerox machines are there, how much energy they are going, all this part of the equipment load. So again, from the electrical engineer, they will give all this load to us to do the calculations to make the energy. Then we have hot systems, hot water systems, have hot water waters, domestic hot water heaters. So all this needs for the domestic purpose hot systems. Again, we need to give the inputs that how much energy is it consuming by the domestic hot water system, right? So normally in India we use geysers. In common buildings we have heat pumps. So there are many types of systems available in the market which are giving domestic hot water. So that is again important to check how efficient the system. The last and the most important, which is ventilation fan flow. So after the code, it is mandatory to give the ventilation systems in building, and we need to check how much the ventilation system is consumed. Again, in addition, there are many sort of equipments available in the market, like MVHR, mechanical ventilation heat recovery. So normally, what is always to the client that use MVHR because we can at least recover going outside free of, so that heat we can recover and use in the building. So this is again ventilation loads. Again, HVAC engineers need to do all the calculation and give the inputs to the energy engineer who will do the energy modeling. So these are all the inputs you can see on the screen that we have envelope and climate data, interior lighting, miscellaneous equipments, occupancy load, infiltration. Infiltration is basically how much air is from the crack or from below the doors. This is again a part of infiltration. This input also we need to get energy model. Then we have fresh air, how much fresh air we are taking from the ventilation system, HVAC system, capacity, COP, heating capacity, COP, thermal comfort temperature. Thermal comfort temperature is basically how much temperature you need inside the building, and you need to give yourself that 24 comfort temperature norm. So that temperature you need to give inside the software. So after giving all the input, you have the output, and it shows that how much the building is going to consume in a year. So on the right hand side of the this table, you can see we have the total consumption, and in this table you can see for the case cooling, it means how much the energy is going for the cooling the building, and then we have ventilation fans, we have miscellaneous equipment, area light, we have task lights also. So whatever the input we give, the output will come accordingly, right? The blank space is saying that we are not using any of these inputs. Energy simulation not only analyzing the building running cost, help in studying a system without doing it in a real time. So what we are doing is we are making a virtual thing and just calculating the things how it's going to work after some years, right? So this too, it's a more than analytical method. So there is a system in which we just compare the parameters of two things. Like one is the baseline parameters and one is the our proposed parameter, design parameters. But better is to just do the whole building simulation, which is the second method in which we give all the inputs of all the system and see how much consumption is coming, and then we can compare the building with the baseline system, right? So this is the summary. Now let's talk about the energy modeling for the existing building. So if we have like existing building 20 years old or 25 years old, and we need to see how we can make this building energy efficient. So for that, we need to do energy modeling. And in this energy modeling, what we do is we just check the 12 months electricity bill. We need to make the calibrated model, and then we need to see how much fraction of that consumption is going on that particular component. Like how much the electricity is going for the lights and for the HVAC. So all these things we need to check. In calibrated model, schedules are very important. We need to have the project manager or the maintenance person there so to know the schedule of the building, like how, at what time they just switch on the lights, what time they are going to use the HVAC. So schedules are very important for the calibrated. So these are the things. Common applications estimate savings from energy conservation measures. After doing the calibrated model, we suggest the client to do ECS, energy conservation measures. Like you need to just change the HVAC systems. You need to install the occupancy sensors. These are the energy conservation measures we generally suggest to client to make the building energy efficient. So this is one the most effective scope of retrofit. You we need to see many more combinations because everything is associated with the cost. So if we are giving everything the best one, it will increase cost of the building owner. So this is definitely not. So we need to see how to reduce the cost also and energy also and give the best combination of all the components. So this is one thing. Determine causes of discrepancies between predicted and actual energy used for tuning of system. Right. So normally, with my experience, I saw that whenever we are making the calibrated model, there is some difference in the consumption of the calibrated model and the actual model because sometimes we are not getting the right inputs from the building, and that's why we are getting the difference in the. So for that, what we do is we do the audit and commissioning of the system. We go on this, we check each everything that how the chiller is working, how much efficiency it is giving, what's the speed at that particular time, and only we can suggest the ECS. So this is one sort of we do for the existing build. Before going to Q&A session, I just want to show you one of my live projects. So, is my screen visible? The software?
Yes, it is.
Okay, thank you. So, basically, on the screen, you can this is one of the commercial office building, which is core and shell, and here you can see this is the interface of EPS software, and on the tab uppermost, you can see there are basically six tabs and to give the inputs. So the building shell, we need to give the inputs of the envelope, like what wall we are going, the roof and the glazing. So, let me show you what I use as roof here. So here you can see I use a baseline wall. This is a U value I'm going to use in this particular building. So for the U value calculation, you can directly give the inputs also, and then you have the layers also. So from layers, you can make the layers like you have brick, then cement, then you have some sort of insulation. So you can make the layers also, and automatically Equus will give you the U value. And if you have a direct U value, so you can just assign the direct U value also. So this is the wall I used in this building, and then we have uh, the U value of roof here, which is again a direct input, and then the glass. So for the glass, we need to give the SHGC or SC. SHGC and SC are the same thing, shading coefficient. Only few of the countries are using SC as a word, and some of the countries are using SHGC. So we have the formula also to convert these values from SHGC to SC. by 0.87. So this is one thing. So in this way, you need to give the SHGC value, and then you need to give the U value, conductance value, and the visible light transmittance value. So these are the three things, three parameters you need to assign here in the model itself. And in the project end side, you need to give the basic data like where is the location. Just show you. See, this is a project address, what weather file you are going to use. So all this information you need to give here in the project. So building shell is all about the envelope, how efficient your envelope is, how you can make the things in the envelope. Here you need to make. Then you have the internal loads. So internal loads, basically we have this sort of things like the occupancy, lighting load, equipment load, infiltration. So all these figures you need to, all these inputs you need to give here to calculate the the consumption, right? So here you can see we have used the parking occupancy, then we have the retail occupancy, then we have offices also. So we need to give the occupancy. So basically, this model is particularly for the lead modeling, in which we need to compare the building with the ASHRAE building, right? So in this way, we need to give all the parameters like what is the LPD. So here we have used 0.25 watts per square meter LPD in the basement, and here we have used 1.4 in the offices. So in this way, you need to give the inputs. You need to check from the drawings from the electrical consultant that how much lights he designed, and that inputs you need to give. Then we have equipments. So equipment load also you need to give here as per the ASHRAE. Right now these all are as per the standard of ASHRAE. Then you need to give the infiltration data also, like how much infiltration is going inside as per the air changes, right? So this is all about the internal loads. And then we have the water side HVAC. So basically in EQS, there are two types, air side and water side. So water side is whenever we are handling with the water, like the domestic hot water, air cooled chiller, water cooled chiller. So whenever we are talking about any equipment which are associated with the water, we need to make the system inside the water side HVAC. And air side HVAC is basically all the refrigerant systems like VRF, split units, window ACs, all this part of the air side equipment, and all the ventilation blowers, ventilation systems, AHUs, all are part of air side HVACs. Today, we are just doing this webinar for the brief introduction, like what is the energy modeling and how we can do the energy modeling. But definitely in future, we'll do the workshop in which I will show you in the detailed format how to create the building and how to make the give the different input parameters and see how the building is working. Okay, so we'll definitely conduct the workshop also in the future. But today we are just talking about the brief thing, how to do the energy model, what softwares are available in the market, and how we are going to use the software for the energy model, right? So in air side, we have all the systems, as I already told you, and then we have the utility and economics, in which normally we give the tariff rates, that what is the electricity rate available in that particular location. You need to give the input here, that how much dollar per unit we need to give here. So this is a basic thing. After giving all the inputs and making the structure, let me show you the structure. This is a 3D structure of the building. So after giving all the inputs, making the structure, you need to calculate or simulate the building. So after simulating the building, it will show us the consumption, that how much consumption is going to work. So here you can see this is the total electricity consumption of this building, and it's showing the graph also that which particular part is taking the more energy, right? So here you can see that the miscellaneous load is again high, because this is commercial building. We have lot of equipments inside, and then the cooling also in the mid months you can see we have more cooling load. So definitely it is going to consume more. So this table basically shows all the 12 months and give us the final yearly consumption of the building. And in that way, you can now optimize the thing. You can make the changes in the HVAC system, right? Like in this project, let me check how much the COP I have used. So the chiller I've used is 3.41, right? So if you have better chiller available and the client is ready to invest the inside the building to make the building system more efficient, then you can make changes in the COP, and then you can again simulate the model and check how much percentage of get how much percentage of reduction we are getting, right? So in this way, we need to do the calculations, and this is the software we are using from long time. But today, these days, we are also working on IES and Design Builder, and there are many other softwares also available, as I told you. So this is all from my side, just for the brief introduction of energy modeling. So now we can do Q&A session. If you want to ask anything, we can discuss.
Yeah. Um, so before I open the floor for others, I myself have one question. Like uh, for building, there is a energy modeling and simulation softwares like eQuest and other. So for industry also, are there some softwares available for industry modeling? Say a particular unit in the industry, say um, what we can say. Um,
Okay. So, ma'am,
any
basically,
cooling tower or
will
any particular unit wise softwares are available?
definitely, ma'am, we can make any sort of building in this softwares like IES, Design Builder, EQuest. So, if we are talking about the industrial buildings also, we can definitely make the building in the EQuest, and then we.
Okay,
So, the software is same for any sort of building, and we can do the energy analysis.
okay, great. Yeah.
Yeah,
So now let's take the question from the audience.
yeah.
And um, first question is from Mr. Tarakad Girdhar. He has also been a speaker on this platform. And his question is, besides the building design stage, during operational and maintenance stages, am I correct to assume that energy modeling and and simulation is same as BMS? Is BMS an application objective of energy modeling?
Okay. So, so this is very good question because BMS is a very good tool to check or monitor the thing how the building is performing, right? So normally, by BMS, definitely we can check that how efficiently our system is working. But if you want to analyze the complete building, like every sort of component, so that inputs from the BMS you can give in the energy model and check in the whole building simulation that how we can make the building. So in by taking the BMS inputs, you can make the changes in envelope also, like in the passive approach. So giving all the inputs, if the client wants that we need to insulate the building from the roof, so that part you can check in the energy model and it will give you the better results. Definitely for the active system, you can definitely check from the BMS that how the system is performing.
Okay, great.
Yeah,
Another question is also from him. So, can you signpost for me any case study of net zero application of energy modeling and simulation for brewery sector or agri greenhouses sector, where CO2 is both a process input and output?
definitely, sir. So we have a lot of case studies in which we do various sort of projects. Myself, I already worked on few of the net zero buildings in India, and definitely please share your mail ID on the chat so that I will share with you the case studies, and then definitely we can discuss.
Okay, great. Um, yeah, so that is very helpful of you,
Yeah,
Mr. Yash.
yeah.
And yeah, and he has also thanked you for that. And he has given his email ID also. So in the meantime, can we have more questions? Any other questions? Yeah. So I think there are no more questions. Anyone? Yeah, no questions at present. And
Okay.
yeah, so that was a great
Any-
session. Yeah, great session. And definitely this energy modeling and simulation insights will help the attendees to explore further on this topic. And whatever is the project, I think each one of them can be a case for energy modeling and simulation, so that we can project like what will be the consumptions of the
Mhm.
buildings later on. So
Yeah.
thank you, Mr. Yash. That was a great session. And we'll be in touch for future programs also. Yeah. Thank you so much. And thanks
Thank you so much.
everyone for attending this session and attending the programs regularly. And if you have any feedback or if you have any particular topics in mind, so just let us know on our email ID, that is aeewesternindia at gmail.com, so that we can arrange those webinars for you. And if you are interested to present your own work and case studies, you can again contact us. Thank you. Just 1 second. I think somebody has, yeah. So, yeah. Thank you, Mr. Giridhar. Uh, you have always been a great support for this platform, and with the people like you, we are and more encouraged to continue this webinar series in the second year, and we hope to continue it for a very long period. Thank you so much. Yeah. Bye, everyone. That's all, and see you all on the fourth Friday. That will be um, on 26th of April. Our next session will be on 26th of April. So keep a watch on your emails and the social media, that is LinkedIn, and you can also see our previous sessions recordings on our YouTube channel. Thank you. Thank you so much. Bye.
Thank you, everyone. Thank you. Thank you for joining. And you can connect on LinkedIn also, so then we can discuss further if anybody any needs any support. Thank you so much.
Thank you.
Thank you.
Thanks, Mr. Ish.